Okay, this is going to be Lab 7. It's going to be talking about strings. So this video is going to be going over strings and arrays. Hopefully you guys have been introduced to them in class, but if not, I'm going to go over real quickly what arrays are like in C, how we can use them, and I'm sure you get into more detail in class later. But for now, just going to go over some conceptual stuff about them so we can use them for the lab. So when we talk about a string in C, what we're really talking about is a array of characters. So a single character, this would be one character, one single character, but a string is a series of characters, all in a row, we'll say. So again, if you guys aren't familiar with array notation, what we can do is I can specify a data type, a name of my variable, and then using brackets and a number like this, I can specify how many of this data type I want to be stored in a row. So this is basically saying buffer is going to be a pointer to a block of memory that is the same size as 16 characters. And let me just illustrate that really quickly. So if I print out buffer just as an integer, we can see that it's some big number. Usually when you see these kinds of big numbers, this means they're memory addresses. So buffer is a memory address, meaning it's the same as a char pointer. It's just this. We're just initializing it slightly differently. And it's pointing at a block of memory that is 16 characters long. Now, what can we do with that memory? Well, let's consider if we had an integer, int I, and I had a pointer to it, int pi is equal to, it's going to be a pointer, and I'm going to say it's the memory address of I. So you guys should be comfortable with these two lines right here. What this is doing, I'm declaring an integer, and then I'm declaring an int pointer whose value is going to be the address of I. So similarly, if I do a quick print statement of pi right here, we can see that it is also a memory address. There we go. I get another big number there. So it's a memory address. And what I can do with pi is, well, I can dereference it. So I can say dereference pi, and I can set it equal to something like 4. And then if I print the value of I as an integer later, we see I get the value 4. So by modifying, first dereferencing this pointer, and then I can modify the value that it points to. So in this case, it points to I. Now, looking back at what we have here, we have buffer, which is a pointer, and it points to the start of 16 characters. So I have a little example showing right here where each one of these boxes represents one character. And we can see I have characters in there. And then the pointer at the bottom represents the value of buffer, essentially. So what I can do is if I were to dereference buffer as is, if I were to say buffer equals G, since it's going to be a character, I have a character pointer, so when I dereference it, it's going to be a character. If I were to say dereference of buffer is equal to G, that would be setting this first element because it's pointing to the first element. Now, what we can do now is, this is why arrays are interesting, and this is why it's important that all of these are in a row, because what we can do now is, instead of just dereferencing buffer, what if I added 1 to it? Well, let's think about it. I take a memory address, and I know that all of these are in a row because that's what this is saying. That's saying 16 characters in a row. So if I add 1 to the memory address, it should be moving the memory address over a little bit and be pointing at the next element. So by adding 1, I'm basically moving this pointer over here. Then when I dereference it and set it equal to G, I'm no longer setting the value of A, I'm actually setting the value of B. So I'm overwriting this. And I can I can demonstrate this a little bit. So what we're gonna do is instead of having 16 characters, because that's a bit long for me, I'm gonna have 1, 2, 3, 4, 5, 6. So I'll say 6 characters, and then I can actually give these values just like this. So I can say A, B, C, D, E, and one more F. Good. So if I print the value, and this is going to be %C because I'm printing a character of just dereferenced buffer. So remember, buffer is currently pointing at the first element. So it's right there. It's pointing at the A. So when I dereference buffer, I should get A as the resulting character. And so I do. So I get A. And as I was doing here, I added 1 to the memory address to move this pointer over. So we can do the same thing. First we add 1. So we add 1 to buffer. That's moving the pointer over to the next position. And then we dereference it. So I would expect it to be equal to B. B, and so it is. And I can keep doing this. So if I do 4, I get E. So that's moving it over 1, 2, 3, 4 spaces. And now I'm pointing at E. We see I'm at the start of E. So I'm going to get the element that's directly following that memory address. And in the next case, I have F. So I don't actually have a 0 here. I have F. And you guys will probably know a much more common notation for this. And that is going to be, I'll show it off to the side so we can see them side by side here. That's going to be buffer with 2 brackets and then the 4 there. So these are going to do the exact same thing. They're just this is a shorthand notation for doing this. So if I compile and run it, we see I get E both times. So this is doing the same thing. It's adding 4 to the buffer, and then it's dereferencing it. This is just a little nicer. It's a little easier to read, and you guys are probably more familiar with this. So now that I know that we can use this notation and kind of how it works, the powerful thing about this is I can put any variable here. I don't have to put a hard number there. I can put any variable. So let's say I put I there. Well, actually, let's say I want to print all of the numbers. We know I would need a for loop here. It's going to run for the same number of elements that I have, which is 6. So I can run it 6 times. On every iteration, I'm going to print 1 character and a new line. And the character that I'm going to be printing is going to be buffer at the index of I. So again, this is going to be buffer plus I dereferenced. On the first iteration, it's going to be buffer plus 0 dereferenced, which is going to be A. In the next iteration, I is going to be 1. So it's going to be buffer plus 1 dereferenced, which is going to be B, and so on. And you can see how this would print out all the letters in my array, A, B, C, D, E, F, all 6 of them. So this is a more array-oriented look at strings. So now let's talk about using strings as maybe something slightly more than arrays. So what we're going to do first is I'm actually going to, let's get rid of this. I'm going to make a new buffer. Oops. I'll make it 16 again. And let's start out by just getting a string from the user. So we've gotten integers from the users before, and how we did that was scanf, and then we used %d as the format. And then let's say we had some integer I would use %i, saying that this integer should be put in this location. So remember, this is a memory address. I'm using ampersand, so this is actually an int pointer. It's a memory address of a location to put this value. I want to do something similar for the buffer, but instead of using %d, it's not an integer anymore, we're talking about a string. And scanf and printf, they treat strings a little differently than just normal data types. And I'll kind of highlight those differences, but let's use %s for strings. And then we know I need a memory address, so it's going to be the location of where to store this. And we know buffer is a memory address pointing to the beginning of a block of 16 characters. So what I can do is I can put buffer here, and there's no need for the ampersand here because buffer is already a memory address. It's already a location, so there's no need. Buffer is not a character, it's a pointer to a character. Okay, so if I were to do this, and then I can do something very similar with printf, where I can use %s to print a string. And we'll get into what this is actually doing. So if I go ahead and run it, it's going to wait for me to enter it. So I'll enter some string, and then I hit enter, and I get some, because it actually %s for the scanf is actually gonna consider the space between these words as the end of the string, so it will actually stop reading at the space. So let me try that again, and I'll say some underscore string, and there we go. So now I get my full output. And there are ways to get around this, but I'm not going to go into that now. That's a quick Google for you guys. Okay, so we noticed that I had 16 characters here. I had 16 characters, and my string was only 2, 4, 6, 8, 10, 11 long. So we know I didn't actually fill this full buffer. And if I were to, let's say I were to print every character individually. That's what I'm going to do right now. And I'm going to print an open and a close bracket at the start and end, so we can see the characters between. And then I'm going to put a for loop right here. And just like before, I'm going to put buffer I, and I'll say int I equals 0, I is less than I plus plus. And I have 16 characters, so I'm going to print the 16. Make sure to declare I out here. And then I'm going to do some string. And we see I end up with some string and then a whole bunch of empty stuff at the end. Whereas if I did the same thing up here, so if I put the brackets around it here to show when the string starts printing and where the string ends printing, we see I get the closing bracket is tucked right up against the end of the word. So this means that the print statement is not actually printing those 16 characters. It's printing only the characters that I've typed in there. And this is the difference between a standard array and a string, because a string actually will have a special character denoting that it's the end. There's no more characters after it. Even though there might be space for characters after it, there's a special character that says there's no more meaningful characters. There's no more data after it. And that is called a null terminator when we're talking about strings. And that's the 0 that I talked about right here. So that's why this 0 is here. So when I enter some string like this, what gets put into the buffer is SOME underscore STRING 0. And what the printf is going to do is it's going to print every single character until it reaches that 0. So when you go ahead and do string manipulations, which you're going to be doing in this lab and most likely future labs as well, keep in mind that every string should end with a null terminator at 0. And we can actually see what the null terminator is, because let's see, what we can do is instead of printing these characters as a %C, what we can actually do is print them as %D. So that's going to print them as an integer. And I added a space so the integers are printing separately. Some string. We can see all the integers that are being print. So I end up with, a whole bunch of stuff in the hundreds, and then I end up with all zeros at the end. So we can see that all these characters, the S, the O, all those end up being one of these larger integers, and then everything else is just a 0. And I will make a quick note that it's not guaranteed that these final ones will be 0. It's only really guaranteed that this one right here will be 0. So that's the one directly following the real characters. And that's just because I never set these to 0. So these zeros at the end here, these 1, 2, 3, 4 zeros, they're actually garbage left over from whatever other program was running on my computer before. If I wanted to manually set these to 0, I can initialize this whole block to 0 by saying equals 0, just like this. And this is going to put 0 in every element of buffer. I'll say that's probably good practice. It's probably good practice to do that. Okay, so what are these numbers? That's kind of the next question. What we can do is, some of you might already know, I can go to a website, my favorite website, ASCIItable.com. And this is just a big table of what every single one of those integers means as a character. So we see I have 115 in that first slot. And we go over to the table and we look at under the decimal. So that's base 10. The other ones is base 16 and then base 8. So I'm looking at decimal. So we're looking at this column. And I'm looking for a 115. So that's all the way over here, all the way down here. And we see it's this row right here. And we see I get an S. Let me zoom that in a little bit. So you see that 115 is an S. And sure enough, the first character in the string that I entered was an S. And we can do this for the rest of them. I won't do it, but let's just do it for the next one. 111. Let's look at 111. That's right here. Is an O. Sure enough, the second character is an O. So the value of each one of these numbers is telling the printf function how to turn those into characters that we can read. And it's actually not necessarily a printf function. It really depends on how your operating system handles characters, but that's something different. So each one of these numbers maps to a unique character, and 0 maps to null. And that's why we call that a null terminator, because a 0 is null. Okay, so now that we have kind of better understanding of strings, characters, what they are, how they look in our programs, I'm going to do a very quick example program for you guys. So what I'm going to do is, let's just take a count of all of a certain digit or a certain character. So let's this used to be part of a older lab, but we're going to be doing different labs this year anyway. So what I can do is I know I'm going to be using a for loop because I want to look through every single character in the input and I want to examine it. And I know I need to make sure I have a count variable, int count equals 0, initialize that to 0. I'm going to be running that for 16 iterations because that's my buffer size. It's also nice sometimes to put the buffer size up here, buffer size as 16, and then you can just use buffer size as that constant. And then what I can do is, just like I was doing before, I can look at buffer at index I, and I can see if it's a particular character. So let's count the number of A's in my string. So I can do a if statement, and then if character at position I is equal to A, then I can say count plus equals 1. And then at the end, let's do a quick print statement. All right, and I forgot my scanf. So let's get that going, %s, and then buffer, again, no ampersand. And then it's gonna be test, and let's do BBA, BBA, A, B, B. And I see I have 3 A's, and sure enough, I do count 3 A's, 1, 2, 3. So definitely use this as reference. Looking at this coming lab, we're going to be doing a lot of string manipulation stuff. And of course, actually, I'm going to be, I'll change this one bit extra and say if it equals A, let's actually change it to C. Let's change it to C. And then at the end, instead of printing the count, I'll just print my buffer. So predictably, this is going to change all of the A's to a C. So A, B, B, A, B, A. Sure enough, all the A's get turned to C's. So we can definitely write to this buffer. We can read from it, we compare to it, just like we would any other numbers, just like you would any other array. But in this specific scenario, we're talking about an array of characters that is null terminated. That's the difference between an array and a string. Okay, so anyway, this should have given you guys a nice, good kind of overview of strings, how to use them, arrays as well, but we won't really be getting into arrays too much. We're just kind of talking about strings as a easy introduction. All right, hope that was useful for you guys. Good luck with that.